Okay. So hi everyone. My name is Roberto. Thank you so much for joining this session, especially considering there are so many good sessions happening at the same time. So I'm really honored for all of you to be here, and I hope that I can make your time be worthwhile, right? So before getting into the actual topic, let me just give you a little bit of overview why I came up with this session, right? So I've been a Java developer for the last 20 years, and just to make something really straight here, I'm not really into anything regarding any performance, anything like that. Nothing. I was never done that kind of work before. Unfortunately, or maybe fortunately, right, depending how you'll see things, right, the current role that I'm working on actually require me to do this kind of work. So anyone here heard about Quarkus before? Okay, a few. Anyone here is using Quarkus? Thank you so much. So part of my work, I'm in the Quarkus team. I'm not going to talk about Quarkus, so don't be afraid about that. But the point is, the work that we do on Quarkus, and if you heard about Quarkus, so you know that we try to make the runtime as lightweight as possible. And because I ended up working a lot on the core, I ended up having to deal with a lot of these issues, especially on how be able to write efficient code that's going to be, of course, less time on your CPU and less memory on your users. So because I have all these struggles when I was starting up, right, and of course I have like really awesome colleagues that help me out on that, then I can try to come up with this session that the idea is to try to bring some of the things that I learned in the last couple of years for people that are also starting this area, or at least if you have some kind of issue regarding performance or regarding how to write some piece of code that you need to be efficient, how you can start up and how you can go and analyze your code and see things that you can improve and things that you can measure and things that you can do better, right? So maybe you heard about this sentence before, or this quote, like premature optimization is the root of all evil. Anyone? Yes, most of the room. That's usual. But do you know that the actual full code sentence is this? Just a couple, right? Right? And actually, when we hear about saying, well, premature optimization is the root of all evil, of course, everything has a context, and the actual context is the entire quote should be, we should forget about small efficiencies. Let's just say 90% of the time, premature optimization is the root of all evil, right? And the point is, sometimes people will use this as an argument to say, hey, we shouldn't optimize this, or we shouldn't do this because, well, you shouldn't be doing that because someone said that a long time ago. But again, you should be looking into the context. And just because someone said this before, and I mean, I think we're totally in agreement with this quote, right? It doesn't mean that you should not be looking at what your application is doing, and you should not be looking on things that you can optimize, right? Sometimes it is fine to start something without having to look into these areas, but at some point in your career, maybe sooner, maybe later, you're going to have to be able to look into these kind of situations and be able to figure things out, right? Now this is gonna be a very practical session, so I have a couple of slides here, and I'm also going to show some code and show some demos. So the demo that I choose here today probably not like the best one, but that's one that I remember. You know, us engineers are really not very imaginative on that. But the idea here is how can we prefix a large number of names, right? So you have like a huge string or a huge list of strings, and now you want to prefix it with another string. So how you can do that? Okay, and that's my first implementation, right? Can you understand the implementation? Yes, very simple, right? So you pack up a list, you have a prefix, you have a list of names, you stream that list, you pass in the prefix, and then you collect them, and you get the list of the prefix names. And I mean, that's totally fine. I think does that work, right? Everyone thinks that works. Yeah, awesome, great. Yes, so that was my first implementation, and that's great. But I was actually getting some troubles with this kind of code. I mean, not that particular piece, but a very similar one. And I'm not sure if you know Game of Thrones. I mean, I'm a very big fan, right? And you know, I just know that I don't know nothing, right? Like Jon Snow. And the reason for this is, right, when you look into the piece of code, I mean, that's a very simple piece of code, but what can you tell me about the performance of that particular piece of code? Can anyone tell me how it's going to perform? No one, right? Because the issue is that you cannot guess. You need to measure, right? So if you don't measure the code, you're basically just going to be another person with an opinion, right? And what you want is you want to have facts. You want to be able to show, hey, I was able to measure this. I run this piece of code. It has that behavior. And now once you have a proper measurement, that's one of the things that I want to call it as a baseline, right? Then you can actually look into that particular piece of code and say, yes, this is the best performance you can get writing this, or we can improve it and rewrite it in some other way. And so for me, these are the very basic concepts on when you're doing this kind of work, right? So you write a piece of code, you can look into that, you'll say, okay, that's fine. Conceptually, like and functionally, it's doing what I do, what I needed to do, right? But do I really need to improve it? We'll see, right? So ideally, what you want is, let's measure it. So one of the tools that I use the most to do these kind of things is called AsyncProfiler. Does anyone heard about the AsyncProfiler before? Okay, just a few. Great. So that's great. I think at least you're going to learn something new from this session. So AsyncProfiler, as the name says, again, is a profiler, right? It allows you to hook up on your JVM, and it will profile the code that you're running. Now, compared to other profilers, he has a very, very small footprint, right? Especially when every time that you hook up a profile, of course, it's going to be an impact on the code, right? But the AsyncProfiler is one of the profilers that has the less impact, right? And that's why I like to use it for doing that particular piece of work, especially because a lot of the work that I do runs on the nanosecond time, right? So sometimes it's really hard to figure out if I'm spending time in one piece or the other. So AsyncProfiler really helps me on that. It hooks up a lot on the native stacks, right? So with the performance events that you have over there, it's open source, right? Everyone loves open source, so you can go there and contribute to that. And especially, it gives you out-of-the-box flame graphs experience, right? So I'm going to show you that as well. But most of the work that I do is mostly like running AsyncProfiler and then running flame graphs to see what's the behavior of my application. There's a couple of other things, but I don't want to go into much detail, especially because that's a new tool. And ideally, what you will do here is you can explore it, and then you can go into more detail later. Okay, so this is an example of a flame graph, right? So it's probably really big. And the interesting piece of this is considering that a lot of times that we run code is not our only code that says running, right? Sometimes it's the runtime that you're using to execute your own code, right? For instance, when you run something in Spring, right, you also have to account with all the Spring stuff that's running. If you're running things on Quarkus, you have to account with all the things that Quarkus is running. So actually, the piece of code that I wrote is just that little bit. And you may ask, well, is that enough, or is it worth for me to go into all of that detail when all of that runtime is doing all of that and I cannot optimize it? Well, sure, but for this particular situation, just an example, right? And again, you can focus on the pieces that you can improve, not the pieces you cannot improve. At least you can look into this and say, hey, these guys are doing something wrong. You can go and open an issue on their issue track, and maybe they can fix it, right? But again, this is just an example. So here are some flame graphs. Here is you can go and dive into this. So this is the CPU. I'm actually gonna execute this so you can actually have a feeling on how that works, right? So here I have an example. So let's go over here. So this is a resource. Let me just put this into, should be better, right? So it's just a resource. It creates like a bunch of names, so like 10K. And then what I want is just to invoke my REST endpoint, and it's going to just append or prefix with a greeting, and then it's just going to output this, right? And here's my solution one, right? So it's been called over there, that's fine. So what I'm going to do over here is Let me just build it for the moment. So I could actually run this in development mode, but I just wanted to do it this way for now. I'm using an old version. I should update that. And now what I'm going to do here is I'm going to run a AsyncProfiler like this. So again, it's just like a Java agent that you plug in into your JVM. So I put here a bunch of commands, well, arguments to my JVM, mostly to make sure that the memory is predictable in the way it works. But I'm not going to go into details about it. But again, it's just like a command, and you run it. So it's just profiling started. That's fine. So my application is running, and well, yeah, I can come over here and I'll say curl hi, and you're going to see that's going to take a bunch of time, right? Because it's just processing all of those lines. But hopefully it should give you something. So here you go. And from this point forward, I already collected all the profile data that I have. So you can just kill this, and you will see that you have here a Java flight recorder. So if you're familiar with Java flight recorder, you can also open the profiling data over there. But what I want to actually do is I'll say, again, use this as a AsyncProfiler converter, which is going to convert that file into the flame graph that I showed you before, right? So now it's a plain HTML file, so you can open up in any browser. So I think I should have it right here. So let's just, there you go. So that's the one that I was showing you. And you can actually go over here and search for stuff, right? So let's see. This one was called greet, right? So we can go and say greet. And you should be able, oh, there you go. So you'll see, here's the greet one, right? And you can drill and you can see exactly what my solution one is doing. So now, even though you didn't have any idea how that was behaving, now you can just look into exactly everything that's being called on that particular method, right? Just that method. And you'll see there's some string stuff opening over there. And there's like arrays growing. There is like arrays list. There is the concatenation, right? So there's some things that happen over there. I'm not even sure if that can be improved or not. But what do you think? Do you think that that can be improved? Yes, a few of those. Okay, so let's see then what can we do about this. So we have solution one here. So do you have any ideas how we can improve?
I would just add the dot only once.
You add the dot only once. Okay, so how we'll do that? Okay, so let's say it's the string. You'll say it like this: prefix only once, right? And you say prefix, and you do it like that, right? And now instead of appending prefix dot, you'll just say only once, right? That seems like a very interesting optimization, right? So now, again, you go on the same process. You can just go and rebuild the app, and then you run flame graphs again, or you run the AsyncProfiler and run flame graphs again, right? But I mean, this is not really optimal, right? If you want to try out different things. So for when I want now that I identified this piece of code that I want to improve, what I do now here is I just go into a different tooling, which is the Java micro benchmark harness. Does anyone know about it? Okay, a few, a little more than a AsyncProfiler. But what JMH does is allows you to build, run, and analyze these micro benchmarks with more detail, right? So it minimizes some of JVM optimization. Sometimes when you run, of course, JVM is going to optimize stuff for you. So you have a lot of control what you're going over there. And you can do like a lot of modes where you want to measure stuff like throughput, average time, right? Sample time, single shot, right? There's a bunch of things you can do over there. So now I have these over here, so I could do exactly what I've done before, but I actually have here, so probably not, I want to hide that. But again, now I put everything here on my Java benchmark. So we use these couple of annotations, right? So of course you can play with the amount of forks that you want. You do like warm-up operations. So just to make it simple, for demo purposes, I'm just going to use 1 for everything. But those are not the ideal numbers you should use when you're doing a proper benchmark, right? So it will depend on what you want to do, right? And it also has this really interesting concept of like a state, right? So you can pre-create a state that's not going to enter on the measurement. So in this particular case, my state is just creating all the list with all the names first. And the actual thing that I want to measure is this solution 1 that I have over here in the bottom. So let me just, which is the one that I added over there. I have another one there, but let's just, I'll just comment this for now. And I can say, so the black hole is just something that will say, please consume this, right? Because I'm not really returning anything over this, just to make sure that that thing executes. So let's put, so I have something over there here. Let's, that was another solution, but we can try with that gentleman example. So let's say solution, let's call it 2 as well. Well, 4, probably. 4, and we'll just take this thing out. Well, not there. So let's go outside. So I think that's better. So IntelliJ didn't really help me there. So I think that was it, right? So now we'll say, okay, solution 4. We call with the prefix and the names, and we want interest in throughput, right? That's what we want for this application. So probably solution 2 is not a good name here. Let's do it to 4, and well, let's remove this for now. And now I can just execute this, and we'll see if there is any kind of improvement, right? So now we'll see. Both are being executed, and what you actually have here is this is a score, right? So it doesn't mean this doesn't mean anything in the sense that, we're going to expect this amount of performance. It's just a score, right? But still, the score gives you some information. Now we'll see that at least on the throughput side, solution 1, which I had, has a score of 2.5K, and the solution 4 that the gentleman kindly suggested, right, gave me a better score, 2.7. Okay, right? So I did a small improvement, right? That's great, and I was able to actually do this very quickly just by using the harness, right? But do you have any ideas how we can improve the code? String builder, okay. So string builder is an interesting one, right? So let's go. I'll still gonna have solution 4. I'll just going to roll back that for a while. That one as well. And let me put solution 4 here. And remove this. So solution 4, there. I don't want to show that one again, but is that what you were thinking? Okay, so now the solution is we have a string builder, and we create one, we append it, right? And we just use 1. So let's see the results for this. I'm not going to run, so free, where is free? So let's just remove this for now. So now let's see how that behaves, right? So again, it's using the solution 1, now it's running with 2, now it's running with 4. And now in the end, let's see, okay. So quite surprisingly, string builder is even worse than solution 1, right? That's a surprise, right? Because I mean, most of us were trained to think that string builder is faster when we want to append strings, but that's not necessarily correct on today's JVMs, right? So that was probably correct like on version 1 or 2, but for some reason that also came through the ages, right? And now actually JVMs are able to optimize a lot on the string concatenation side. So actually, in many cases, when you're actually doing this, it's going to be a little bit worse. And again, don't feel yourself bad, because I had the exact same situation when I was looking into this, and I was very surprised when that happened, right? And just for say that sometimes what we think is going to improve is not necessarily correct. So that's why we have to measure all the time the things that we do, right? Because sometimes when we do code, we actually make things even worse than they were before, right? Now, there is another reason why string builder here doesn't really, it's a little bit worse. Can anyone spot why? It's in a loop, exactly. So you can always argue that, okay, this one is also in a loop, right? And that's true. But again, the way that JVM looks into this concatenation is actually even better than when using the string builder. So even if both are the loop, JVM is even able to do that in a better way. So I came up to this other, which called solution free, right? And so what you can see here as a difference is, okay, I start an array. So actually the array has a couple of other things. So it's actually already pre-selecting the size that I'm going to require. And the string builder is actually outside of the loop. So in the loop, I'm only going to append, right? And because I'm using the string builder, I'm just going to reuse the string builder all the time. So in the end, what I'm going to do is I'm going to reset the string builder to the size that I need, just to keep the actual prefix and then append the next one, right? So it's just like reusing the same string builder, but just the pieces that I want, right? So now, does that make any sense? But it's not really that great, right? All of you will prefer this one, at least code-wise, right? No? That's fine. So yeah, let's run with free now. So it should be right here. Let me copy that one again. And let's put 4. Okay, so I think everything's fine. So now let's run. And let's see if that actually is better. Okay, so 1 is 2.5, and 2, as we've seen, was bad. And the one that General was suggested is actually the best, well, not the best compared to 3, but the best compared to 1 and 2, right? So I'm probably going to give it as an example as well. But if you look in our solution 3, you'll see that's actually a big difference, right? You can actually tell, at least, even if it's only a score, now you'll see that's actually a better implementation, at least just to that particular piece of code. Now that I'm actually happy to see, okay, now I have like a better implementation. So you can now go to your actual other project, right, on my resource, and I already have it right here, of course. So I'm just going to come over here and just going to replace the method name and call it free, right? So now I'm going here to my terminal again. I'm just going to build the app with a new solution. I'm just going to run the AsyncProfiler and the flame graphs to see if I spot any differences, right? So here is the AsyncProfiler. So it's starting. Just going to invoke the endpoint again. So probably not going to notice much difference on the time, because we're talking about some milliseconds here, but still. So now it's done, and now you can run the flame graphs again. So let me just rename these to free. Okay, there you go. And now let's open that one up, and that was -3. And that was Greek, I believe. Yeah, there you go. So do you notice? So now looking side by side, right? So probably here. Let's put it like this. Grid. solution 1, and there's solution 3. See how much clean the solution 3 is in terms of things that being executed, right? So on solution on this one over here, so let's put this now a little bit bigger. Again, you'll see, of course, there's a lot of things happening, doing the stream stuff, and because we didn't start with like a proper array, so we have to pretty much grow the array all the time, depending, of course, on how many elements I'm adding over here. So there's a bunch of things happening, but this one over here, now you'll notice, is very, very clean in terms of execution, right? It's just say, it calls a string builder to string, and does a copy of range of the string, and that's pretty much it. You don't even notice the elements being added to the list, right? Because it's very, 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 very fast. If you notice here on the, probably it's not a very, well, actually, I think you can read it. Sometimes it's small. So you can also always see, if you go on the solution 1, you'll see that it was actually, I'm collecting samples of the allocation of memory in this particular case. You'll see that for the entire execution of the runtime, it takes like 1.18% of the entire allocation sample of the app for 700K samples. And this one over here, it's way smaller, right? You'll see it's 550 and less than 1%, right? Of course, I mean, these numbers are related, but again, you get the idea. So the idea of this example was to guide you through us looking into a piece of code, identifying the piece of code that we want to improve, then go through several iterations, and then in the end, you actually get something better, right? So that was the goal. Okay, so let's come here to the slides here slightly. Okay. So do you think this is worth it? Right? It depends, right? That's a very good answer. So yes, I mean, sometimes we have to go into all these lengths, right? And especially if you listen to this particular example, you may say maybe it's not worth it, right? But in many cases, it's going to be worth it, right? So you have to look into your application and see what are the possible bottlenecks and go and optimize those pieces, right? So the goal is, when you look into a flame graph, is not to go crazy and optimize all the stuff that you can see, but of course you go and see, let's just say that REST endpoint's being called like multiple times per day, right, or per hour, whatever, right? So you may want to look over there and try to optimize those particular pieces, right? So you have a better experience, right? Even though, of course, I exaggerated a lot of the numbers because 10K it's quite big, and so the actual response that you get takes a lot of time, right? So you're probably not going to notice how much time it took from the first execution to the second one. I can probably measure that as well. But if you can save, I don't know, maybe 100, 200, 300 milliseconds per REST endpoint, when you have like in this particular example, right, it may be worth it, right? So that was a very naive example, let's just say, right? So now I want to actually go for you and say, how about a real requirement, right? So as I told you, I work on Quarkus. I work a lot on the Quarkus core, and I do a lot of the configuration stuff on Quarkus. So I came up with this requirement. They say, hey, for configuration, we want to match the environment variables, right? So that's a very standard thing to do, right? You want to configure your application, you set up some environment variables, and then you have to match them with whatever configuration the runtime has, right? But as you know, environment variables have some specific rules. They don't allow all the characters, especially depending on the terminal, right? But so there is like some subset. So I got handed these requirements. So you say, you want to match and say, okay, here is the configuration source, and if you have an environment variable, we'll have to match it like an exact match, saying like com acme.size, no matter if it's uppercase or lowercase, so it's like exact match. or you want to match it with underscores. And in this particular case, what you do is you'll pick up that and then you'll just replace it with underscores and match that again. Or replace each characters with that are not alphanumeric with an underscore, do uppercase, and now match against that, right? Is these requirements clear? Okay. So this was my first implementation. I'll show you here. I'll show you here the code. So actually, let me see if I have it right here. Not that one. So let me open this up. And so I should have prepared these before, but it doesn't really matter. Show history. And we can probably go to this one, I believe. Okay. Okay, so this was my first implementation, pretty much. I mean, give or take a couple of difference, but if you read the code with me, you'll see, okay, so there is a cache. Okay, there already has a couple of things here. I probably should not be doing that, but so there's a map with environment variables. There is the exact match, right? So you do like on a map, you go properties, you do that get from that name, right? And if there is no value, if there is a value, return the value. If not, you go and say, well, replace. There's this method here called replace non-alphanumeric by underscores, and now you call that again. And if there is a value, return that value. And if not, you'll just turn that into uppercases, and now you'll just return the value. Or in the end, if you didn't do any matching, you'll just return null. Does anyone agree with this code? You agree, right? But did you notice that it is doing exactly what the requirements told you to do, right? So if you look, I mean, give or take, but it's just saying, okay, you match by this, you match by that, and then you match by that. So if you pick up the code and compare it to the requirements, it's pretty much like a translated copy of the requirements to the code, right? But can anyone see any issue with that with code? Sorry? Put them in on the same cache. Let's just forget the cache for now, right? So the cache was something I made a lot of interest. I shouldn't show that. I said I was not showing. I shouldn't show that version, but I should show the version without the cache. That was just an example that I tried. But yeah, the issue is actually not on the cache itself. The cache was just something that I tried to put over there to improve it. Now, one of the issues with particular piece of code is that I'm actually creating like 3 different strings just to do a match. Right? So the first string that I have, the second string that does the alphanumeric change, and then the first string that does the uppercase, right? And unfortunately, the JVM, even though it's super fast, transforming string is actually a very heavy operation. So in this particular case, what you have over here is you want to do like a lot of matching, and now I'm just transforming strings all over, like, okay, transform these characters, now do uppercase, and every time you do that, you just create a new string, which is going to generate more allocations on JVM instead of memory, and it's going to spend more CPU just doing all these operations. You may think, okay, this is like small things, right? But in the context of Quarkus, and especially now that you have, not only on Quarkus, but especially now that you have native image compilation and native image executables, right? When you have these runtimes that run on milliseconds, these operations start to show up, right? Now, when you run on JVM mode, it doesn't show up that often, or it's not really that noticeable. But in this particular case, it was becoming noticeable, right? So I'm not going to go with you doing the code. I mean, we could, right? But it's gonna, for you to have an idea, it took me like weeks to have like a final satisfying implementation. And I'm going to show you here how it looked like. So let's close this one. I actually have here the other one. Yes, actually have it here. But the new implementation, actually what it does is something like this. It created like a new object, right? And the reason why I have this new object was just to override equals and hash code. And now what I actually added was a specialized equals and hash code that does all the comparisons without having to transform the string, right? And as you can see, it's quite complex, right? So it's not something that you will want to do, right? And probably probably I don't even remember a lot of that code. But if you run, now I'm going to run the micro benchmark to the other solution, to this one, right? And now you'll see the original one has this score. The other one has a 50% increase on the score, right? Which is very a massive improvement, right? It's not even, I mean, it's comparable to the other ones that we were doing, right? But again, you'll see the improvement that you have. And sometimes you have to go to these lengths of writing a lot of code to be able to squeeze this. Now again, you may be asking me, was that worth it, right? I believe so. And why? So this was the PR where I submitted that change, as you notice. So I make some comparisons on the JVM mode and the native startup, right? A lot of these things are actually being very noticeable on the startup and the memory on the native image side, right? But you'll see that you get like improvements on every bit, right? And sometimes very noticeable improvements, especially on the startup time, right? Because the startup time does a lot of string comparisons and matching. So I was able to, just with that change, I was able to reduce the startup time of Quarkus from 25 milliseconds to 17, right? So you can tell me, yes, that from 25 to 17 is hardly noticeable when you're running, right? But when you're running things on the cloud, right, and you have to pay the CPU that you use, the memory that you use, right? Now, if you're running like multiple nodes, these things are getting more noticeable, especially at the end of the month when you have to pay like a huge amount of dollars just by running your applications, right? And that's one of the things that we try to do as well, try to lower the footprint of everything that we do. I've done a lot of other things, and again, here's another example. So sometimes the interesting part of doing that kind of work is that you're doing this work, right? And then some other person, and I mean, is not, don't take me wrong, right? That's how things are. Some person introduces a new feature, right? And of course, new feature has more operations, more allocations, more CPU. And then in the next version, things get worse again. And now you have to go and improve it again. And it's always like this kind of work. You just, someone break it and you improve it. Someone break it, someone improve it. It's a fun thing to do anyway, if you like doing it. So again, here is another example of, in this particular case, I have done a lot of other changes, not go into them, but just to show you that you can actually, when you're doing this kind of work, it can actually be really rewarding when you see these numbers in the end, right? And especially your colleagues and people that use your runtime are also going to be happy when they see those, right? But as I told you, if you notice here, I think this was on version 3.5. So we reduced to the startup time to 17 milliseconds, and then now on version 3.6, that's already on 19. So someone did something. Maybe it was myself. I don't know. I do that a lot as well. Improved to we decreased or we downgraded or introduced a regression that put the startup time to 19 milliseconds. Now improved to 16, and this was my last one, which were again on 20 milliseconds, and now I was able to reduce that to 15 milliseconds, doing a lot of things, right? Now, the interesting thing about this work is it requires you a lot of business knowledge to know that, okay, you can do things other ways, right? It's just not about rewriting how the structures that you use. Sometimes it's just thinking the problem in a completely different way to be able to improve things, right? And usually what I most of the focus more is a lot of the work that we do is always like, okay, you go to the database, you take this object, now you put that object, and now you put that on the REST endpoint, and you allocate. So a lot of our stuff that we do is just allocating objects and creating new stuff, right? And one of the advice that I do is just go and reduce your allocation, because those are also going to impact how the CPU performs, right? So if you have less allocation, it's also going to require less CPU, right? Sometimes there are things that are, of course, are like CPU bound, but in most cases that I work on and that I see is allocation issues, right? Things that you can do without allocating so many objects. So 1 billion row challenge, and now this is the part I'm going to mention AI, because every session has to mention AI, even though I don't do any AI. So this will actually mention on the keynote, which is quite fine. So if you see that over there, right, you go over here and you'll see, so for people who are not aware with this, I mean, it was already mentioned on the keynote, but the idea is that you want to process 1 billion line of lines from a CSV file and want to do it as fast as possible. And of course, if you see that, there's actually Thomas over there on the top. And yes, I mean, you have to go into very great lengths, I mean, to be able to do that kind of performance, right? So if you actually curious to see the code, I don't even understand it, right? That's not the point. If this opens, I should have opened before, but if you're curious, go over there and check it out. Now about the AI part I was mentioning, right? So try doing the challenge with AI, right? So someone tried and it took like 5 minutes to process that. So hopefully we're not gonna lose our jobs yet. So I'm mostly done, right? So I want to go back to the previous sentence or the previous code, right? Which premature optimization is the root of all evil, right? That may be right, but that doesn't mean that you're not going to be able to go and inspect your application and see things that you can improve. Now, sorry. So do you know what is this? So this is the engines of Raptor. So actually, if there is a slight modification here, because this is like mirrors, right? So they started with the one on the right, and they improved to the one on the left. We actually do the opposite. We start with very clean code, which we really love, and then if you want to really have peak performance, you have to go into all these lengths to have all these knobs to be able to control. So it's actually quite fun that in the end the code doesn't really look that great compared to it. But I mean, you could go on assembly, right, and do that on assembly as well. Probably going to get even more, right? But it's always a balance on what you do between achieving good performance or good behavior compared to the code that you write, right? So all of this is about choices, right? So ideally, you want to identify the critical paths of the application that you want to improve, right? And forget about the rest. So sometimes you have to sacrifice that beauty of the code by convenience. Don't get obsessed, right? So I know some people get obsessed about, okay, let's try to do all the things. So try to go for what we call the low-hanging fruits, things that you can improve very quickly, and things that you know, okay, we're going to just do this in like half an hour and just going to improve the situation for the entire app or for the entire user base, right? Instead of just going for like very small gains for features that people don't use that much. So you have to learn how to identify. Then again, using flame graphs on your runtime of the app, you can clearly see what are the pieces that you may want to go through. Measure, right? Always measure. You always have to have a baseline. You always have to know the improvement that you just wrote. And be critic. Sometimes the numbers were going to tell you things that you don't want, right? Or maybe you think that you want, right? As an example, the string builder, as all of us think that we're going to get better numbers. In the end, it was not that way. And learn, right? So I did learn a lot about doing all of these things, and it was quite an experience, right? So I think I'm pretty much out of time. I'd like to thank all the time that you also spent with me here today. Probably don't have any time for questions, so sorry about that, but feel free to find me here after the session or in the hallways, and I'll be happy to answer any of the questions that you may have. Thank you so much.